Guys, and happy Tuesday. I'm sorry I'm not with you today. My daughter, unfortunately, is still sick, and so I'm having to stay home with her today, give her lots of snuggles, and make her hopefully feel better by the end of the day so that I can be back with you guys tomorrow. If you would, please get out your notebooks and turn to pages 55 and 57 and set up your notes Cornell style. On the board in red is written the essential question for page 55, and in blue is written the essential question for page 57. I'll just go ahead and have the sub pause the video right now so that you guys can have some time to set up those note pages and write down those two essential questions. Okay, so now that you have the essential questions written down and you're ready to rock and roll with some notes today, let's go to page 55 and we'll talk about how do I convert moles to mass or converting moles to grams. Just a quick recap of some of the things that we talked about last week with a mole. First thing I want you to remember is that a mole is a quantity, and that quantity is equal to 6.02 times 10 to the 23rd whatevers. You could have a mole of anything. You could have a mole of textbooks. You could have a mole of pennies. You can have a mole of shoes. But what we talk about in chemistry is moles of atoms and molecules and compounds. But with that idea that a mole is a quantity, it's important to understand that 1 mole of pennies, the actual number of pennies that there are, would be equal to if I had 1 mole of bikes, right? In both cases, I would have 6.02 times 10 to the 23rd objects. But even though the number would be the same, their masses would not be equivalent. I think we can all agree that 1 mole of bikes would weigh a lot more, right? 1 bike weighs a lot more than 1 penny. So then if you have 6.02 times 10 to the 23rd bikes, well, that's going to weigh a lot more than a mole of pennies. So just get in your head that idea that a mole is a quantity. It's a unit of counting that we use in chemistry. And the reason, again, that we use it is because atoms and molecules are so small that we need to have a really huge number, like a mole, to be able to actually quantify them and count them in a way that, like, we can see with our eyes. So this is a key idea right here. And just as an FYI to you guys, if at any point in the video you think, gosh, Mrs. Hyatt's talking way too fast, this is just, slow down, Miss Hyatt. Just have the sub pause the video so that you can get caught up in your writing and making sure that you are still doing your best to pay attention and listen. So here in red, to convert between grams or to convert from a mass and moles, you need to use the molar mass. So this is true for what we're going to talk about on both pages of notes today. Last week, we talked about how to calculate molar mass. And if you remember, we list out all of the elements in that compound. We find their individual masses on the periodic table, and you round that to 1 decimal place. Then you multiply that individual mass by the number of atoms that we have, and then you add all those masses together. And if you don't remember how to do that, I would just encourage you to go back and look in your notes and make sure that you can remember how to do that. Also, just a quick reminder, you have a homework assignment on calculating molar mass. Had I been here today, I would have checked it today and it would have been due today, but because I'm not here, it's your lucky day. It's not going to be due until tomorrow. So there should be absolutely positively no reason that that homework's not done because you got an extra day. So please make sure that you have your molar mass worksheet finished and completed for tomorrow. So, like I said, you need to be able to calculate molar mass in order to convert between moles and mass. So, title this section in big, underline it so that when you come back to your notes to study, your attention is drawn here. This is the part where we're converting from moles to mass. So I like to put a little question mark or a little X above mass because that's what the problem, the word problem that I'm going to give you, that's what it's going to be asking for. It's going to say something like, what is the mass? Or calculate the mass. So X or question mark is the mass. That's what we're trying to get to. And what we've been given and the information that we know is moles. And so with that information, we're going to multiply the number of moles by the molar mass. So now that you have that written down, or maybe you don't, we'll leave it on the screen for a little bit longer. Please take the time right now and write down this, this practice problem. What is the mass of 6 moles of calcium fluoride? So as you can see in this problem, like I was talking about earlier, it says what is the, so that's what we're solving for, is mass. What is the mass? And we know that we have 6 moles of calcium fluoride. So I told you that you're going to have to use the molar mass, but I don't have a chemical formula in here yet. I've got a chemical name, and that chemical name is calcium fluoride, but that's not a chemical formula. So I need to first convert that, well, write that as a chemical formula so that I can figure out what its molar mass is. So jogging your memory back 2 chapters now, we're going to take calcium, and if you look on your periodic table, calcium is a metal and fluorine is a nonmetal, and so that's going to form an ionic bond. And if you remember, to come up with the formula of an ionic bond, we use the crisscross method. So we need to figure out what calcium and fluorine's individual charges are. Looking at your periodic table, calcium is +2. Fluorine is -1. So when I take those charges and I crisscross them down here like that, we get CaF2. So that is the chemical formula that I need to be able to calculate the molar mass. So this will help refresh your memory on how to calculate molar mass. We are going to list the elements. We've got calcium and we've got fluorine. We're going to find their individual masses, and that's the mass that's listed on the periodic table. So turn in your notebook to the front and find the mass of calcium. Also find the mass of fluorine. When you do that, you find that calcium has a mass of 40.1. And remember, we're going to round it to 1 decimal place. Fluorine has a mass of 19.0. Again, I got both of those numbers from the periodic table. Then we need to multiply each of those by the number of atoms of that element. So calcium, we only have 1 calcium. There's no subscript in there. So if there's no subscript, we assume that it's 1. So that 40.1 is multiplied by 1. And fluorine, we have a subscript of 2, so we're going to multiply that 19 by 2. So as we equal those over, 40.1 times 1 is just 40.1. 19.0 times 2 is 38.0. And then to find the molar mass, our last step is just to add them up. 40.1 plus 38.0 is 78.1 grams over moles. Remember, units is really important, and you need to be able to remember that those are the units for molar mass. Okay, so now that we have the molar mass, if we go back to this blue part right here, it says to convert from moles to mass and to calculate that mass, we need to multiply the number of moles by the molar mass. So the problem has given us 6 moles. That's the number of moles. And we now know that our molar mass is 78.1. So we're going to go ahead and take 6.00 moles times 78.1 grams over moles. And if you're a math person, you can see that this mole right here and this mole right here are going to cancel each other out because they are on opposite sides of a fraction. So when we take 6 times 78.1, plug that into your calculator for me just so you can make sure you're doing it the right way. And you should get 468.6 grams of calcium fluoride. So if I had 6 moles of calcium fluoride, which is a lot of moles, it would have a mass of 468.6 grams. Okay, so now that we've done one practice problem, please take the time right now and write down this next practice problem. What is the mass of 5.08 moles of potassium nitride? It's going to be a very similar problem to the last one. So the key ideas that we need a chemical formula, and from the chemical formula, we need to calculate a molar mass, and then we're going to take that molar mass and we're going to multiply it by the number of moles. So starting with the chemical formula, we have a chemical name, potassium nitride. And again, potassium is a metal, nitride is nitrogen, and that's a nonmetal. So potassium is K, nitride is N, and you're going to look on your periodic table to see what charges those atoms will form in an ionic bond. When you go ahead and look at your periodic table, you'll see that K forms a +1 cation, and N, or nitrogen, forms a -3 anion. So when you crisscross that, you get a chemical formula of K3N. So now that we have our chemical formula, we can go ahead and calculate molar mass. So we list our elements, K and N, and we need to find their individual masses on the periodic table. When you look that up, potassium, or K, is 39.1, and nitrogen is 14.0. Then we're going to multiply those individual masses by the number of atoms that we have. So if you can see in the chemical formula, we have K3, so we need to multiply that K value, the potassium mass, by 3, and then N. Since there's no subscript, again, that means that we only have one of them, so we just need to multiply the nitrogen by 1. So I can do the nitrogen one in my head. 14.0 times 1 is just 14.0, but then plugging in the potassium, 39.1 times 3, that is 117.3. And then last step, add those together to get our total molar mass, and we get 131.3 grams per mole. So that's our first few steps. We've come up with the chemical formula, we've calculated the molar mass, and then now remember to convert from moles to mass, we need to multiply the number of moles by the molar mass. So looking in the problem, we have 5.08 moles. So really, just to bring some clarification to this problem, the 131.3, that tells us the mass of 1 mole. So if I had just 1 mole of this substance, it would weigh 131.3 grams. But I have 5.08 moles, right? And so I have to figure out how much that's going to weigh. So we just multiply them together. 5.08 moles times 131.3 grams per mole equals, and when I multiply those together, this moles cancels out with that moles, and I'm left just with grams. And my answer will be 667 grams of potassium nitride. And that is how you calculate mass from moles, or converting moles to mass. Once you have that written down, please go ahead and turn to your next page of notes with the essential question, which is pretty similar, just backwards. Now, how can I convert mass back to moles? We're just going to be going backwards now, and I bet some of you already can figure out what the math is going to be. So coming here, how do I convert grams to moles? So write a big heading again so that when you are coming back and doing these or studying these notes later, you'll be able to know exactly where to look to be able to find how to do it. And what you're going to do is you're going to take the number of grams that the problem gives you and divide it by the molar mass. So I'll give you some time right now. Please write down that blue how-to instructions and then take the time to write down this first black practice problem. So the problem says, how many moles are in 205 grams of carbon dioxide? So just like we did in the last problem, these kinds of problems, they give you mass and they're asking, or question mark, or X, depending on how you want to look at it, they're asking for moles. That is what we don't know. So we know what the mass is, but we're trying to figure out, okay, let's say that's how much I have. How many moles is that? How many quantities of moles? So just like when we were flipping it, we multiplied. Now we're going from mass backwards to moles. So we're going to do the inverse operation. We're going to be dividing by the molar mass. But the first step is the same. It gives us in the problem a chemical name, but I need a chemical formula. Carbon dioxide. This one's a little bit different than the ones we were doing on the previous page of notes. Carbon and oxygen are both nonmetals. So when you have a nonmetal bonded to a nonmetal, that should ring a little bell in your head. That is a covalent bond. So we're not going to be doing the crisscross method. Not at all, because then you'd be putting together two negatives and it just get all kinds of confusing. So covalent bonds and covalent compounds is where we use things like di or prefixes. So carbon has no prefixes. And we never start with the prefix mono. So that tells us since there's no mono in front of it and there's no other prefix that we only have one carbon. Di, if you look back at your gold sheet or you just remember, di stands for 2. So we have 2 oxides. Oxide is oxygen again. So CO2. You might have already known that just by reading carbon dioxide, but now you can have a brief refresher on how to write a covalent compound. So CO2, we need to find the molar mass of carbon dioxide. Again, we're going to list the elements in our compound, carbon and oxygen. Then we're going to refer to the periodic table and find their individual masses. When you look at the periodic table, carbon, when we round it to 1 decimal place, has a mass of 12.0, and oxygen has a mass of 16.0. We only have 1 carbon, so we're going to multiply that by 1, and we have 2 oxygens, so now we need to multiply that by 2. Figure out what that is. This is 12.0, this is 32.0, add 12 plus 32, and you get 44.0 grams over moles. So again, first steps are pretty similar. Come up with a chemical formula, figure out the molar mass. Then we are given a mass in the problem. We know that we have 205 grams. And we know that if we have 1 mole of it, that's 44 grams. So how many moles are in 205? Well, we need to do some division. So we take 205 grams divided by, well, that's not very good, divided by 205 grams divided by 44 grams in every mole. And when you divide that, you get that 205 grams is approximately equal to 4.65 moles of carbon dioxide. And it is okay that we have a decimal like that. Mole amounts don't always have to be whole numbers. It's totally acceptable that we have 4.65 of a mole. Okay, so that's one example of going from mass to moles. Now let's do one last example. Please take a few seconds right now to write down this last practice problem. How many moles are in 333 grams of barium fluoride? So again, same overall 3 steps. We have a chemical name. I need to come up with a chemical formula. Then once I come up with a chemical formula, I'll come up with a molar mass. That's step 2. Then I'm going to take that molar mass and I'm going to use it in converting this mass to moles. So barium fluoride, you should ask yourself right away, is that ionic or is it covalent? Barium is a metal, fluorine is a nonmetal. So that should tell you and clue you in that that is an ionic compound. Ba is barium, and if you look on your periodic table, it has a charge of +2. F is fluorine, and that on your periodic table has a charge of -1. When you crisscross those, you get BaF2. Then again, list the elements in the compound and find their individual masses. We already did fluorine, and I remember that from earlier. Fluorine has a mass of 19.0. And then as I look at my periodic table and find barium, I can see that barium in the second column there has a mass of 137.3. Then you multiply that by each of the individual, like the numbers of each of the atoms. We've got 1 barium and 2 fluorines. So this is still 137.3, and then 19 times 2 is 38.0. And we're going to add those up. 137.3 plus 19, or sorry, excuse me, plus 38, we get 175.3 grams per mole. So now we have the molar mass. We need to take the number of grams and divide that by the molar mass. So the problem tells us that we have 333 grams. So we're going to take that and divide it by 175.3 grams per mole. And when we plug that into a calculator, we get 1.8996. So we're just going to round that up to 1.90 moles of barium fluoride. So now you know how to convert from mass to moles and convert from moles back to mass. So what I need you to do now and for the remainder of the period, first thing is on the bottom of page 57, I want you to give me one summary for 55 and 57. So just group it into one. I'm only going to be looking for that summary on page 57. So then once you've written that summary, you have the remainder of the period to work on your second homework assignment. It's the second page in that homework packet that we made. If for whatever reason you did lose it, I have extra copies up on my front table, but it's called grams/moles calculation worksheet. Please work independently. So not talking quietly, but you may listen to music if that's going to help you focus. This assignment is due Thursday, May 2nd, so you have 2 days to complete it. On Thursday, May 2nd, there will also be a quiz. So please make sure that you come with questions tomorrow or Wednesday so that we can clear up any questions you have so that Thursday, 1, your homework assignment's done, and 2, you're ready to go on that quiz. Please be respectful for the remainder of the period and make sure you're getting all those assignments done.